we're going to talk about using data structures in VB.NET to create lists of these objects that we've been defining in our classes. If you pull down the VB Intermediate Demos repo from GitHub and look inside of the 10.30.12 folder, you'll see there is a solution called Candy Project _ no code. I'm using that as a starting point for the code that we'll be building off of this. So before we do anything else, I want to create a new class, and I'm going to call it Candy. And what we're going to be doing in this example is we're going to have a form as you can see here, and we're going to be using it to track the candy that we got from trick-or-treating. And I'll come back to this more after we've defined our class. Inside of our class, we want to track 3 different attributes. I want to track the name, the flavor of the candy, and then the quantity as well. So if I got a bunch of red suckers, let's say 3 of them, and then I also got 2 green suckers, I want to be able to track those as separate instances inside of my candy bag. If I got 1 more red sucker, I should be able to update that quantity. So at any point I can look and see all of the pieces of candy that I have. So if you're doing this along with me, pause the video and see if you can define the class private variables, the class properties, the default constructors, all necessary to support these attributes that would be available in the class. Okay, so the first thing that we do, since we have our attributes, is we're going to go through and we're going to declare a private class variable for each of these. Underscore name, underscore flavor, and underscore quantity. We use the underscore as our naming convention and lowercase letters. For each of these now, we need to be able to declare class properties so that we can have our getters and our setters associated with these attributes. Public property, uppercase N, name as string. After that line, remember, we don't get that auto generation of that code block. We have to type get and then hit enter, and Visual Studio will generate the rest for us. After that, it's a matter of plugging in our private variables to get this working as expected. Lastly, a property for quantity. But I don't think I want to be able to allow anyone to update the property just like this. To me, this is something that's a little more integral to the behavior of our class, where we wouldn't allow someone to say, hey, we have 10 of these, now we have 20. I want to be able to control how that input comes in and out. So instead of just having it as a regular property, I'm going to make this read only so that they can retrieve the value but I don't want them setting it. And so after we say read only right off the bat, we get this red squiggly to say that's not allowed, and we're going to get rid of our setter. To replace that, instead, I'm going to declare a public sub. I'm going to say, call it add1. And what this will do instead is that when we get a new piece of candy that matches this particular instance, we're going to add 1 to our quantity. And this way what we're saying is you can add one of them, but you can't add 20, you can't add 30, you can only add one at a time. On the same note, we're also going to say sub eat 1. And this will have the opposite effect of removing 1 from our bag. Okay, so now we have our class here. We have our 3 private class variables. We have property name, property flavor, and read-only property quantity. 2 class methods, add 1 and eat 1. So let's take a closer look at what we have going on in the form. Now I've gone through and I've added and done the naming so that we can start a little faster along here. But you'll also see we've kept with our practice of giving us some default values. And this way we don't have to go in and keep adding in those values every time we want to test something else. So I went with a red sucker. I have my list box here that's going to track all of the things in my bag. And then I'm also going to have this where I can add the candy or eat a piece of the candy here that's been selected in the list box. So let's take a look and see what we have. Now, when we talk about tracking a bunch of instances of our class, in this case they'd be pieces of candy, immediately what comes to mind is something like an array. And we've seen that working with arrays directly can be a little tricky, and so what we've been using so far is something called an array list. And we'll create a public array list variable on our form. And we're going to use this to track the pieces of candy that someone has added to our bag. Because of the type of data that this is, we have to do some initialization, or what it's really called is we have to instantiate that array. So in my form load, I'm going to say rCandy equals new array list. And now I can use this to add my pieces of candy into it. Now I'm a big fan of doing incremental development. So on my button add, I'm going to hard code in my new piece of candy. And we're going to set it to be the name equals sucker my candy dot flavor equals red. So every time this button gets clicked, we're creating a new instance of our candy class. And the next step after that is, well, we've created it, but because of the way that scope works within this sub, once the sub has finished executing, we're going to lose this instance of the class, but not if we add it to our array instead. rCandy.add and then add my candy. And so what we have here now that this is completed is it will take this instance of our class and it's going to add it into the array list. And what's important to realize here is that it's adding a copy of this. It's got all the same variable values, name and flavor, and it's copying it into the array list. So even though this sub is done executing, we've copied it into the array. And remember, the array list is a public class variable on our form. So that copy is going to exist, but this one no longer does. Now, we've also decided that we want to be able to display all of the candy we have in our bag in this list box. So we want to have a way of taking what's in that array list and displaying it inside of the list box here. And really what we want to do is, after someone has added that to our list box, we're going to want to have a way of updating what's inside of this array and displaying it to the list box. So what we should do is we should define a sub that will in fact update our list box. And what this will have is, inside of it, what we want to do is we want to loop through the contents of our array from 0 to count -1, because our array is 0 based. Inside of this array, for loop, we're going to say lstcandy.items.add, and then rcandy I. We're also going to want to clear out the contents of that list box every time so that we don't get duplicates. And now what our job to do is, now that we've defined this, after any time this array list has been updated, we also want to have those changes reflected in our list box. So add candy, and well, it looks like we're getting some action here. However, it doesn't say anything about a red sucker. It's saying candy project.candy, candy project.candy. And what that is actually, it is adding an instance of our candy, but we're adding the instance. And so because it doesn't know how to interpret that, it's making its best guess, and it's actually displaying the type. And you'll see here it says candy project.candy. Candy project, well, it's the name of our project, and candy is our type. So this is the namespace, and this is the class name. So this is displaying a class type. So we actually have to help it along and say, really what we want to say is the name as a string. And this way, that is what we're getting. And to this point, we're not checking for duplicates inside of our list, so we're not worried about quantity or anything like that. But what if we do want to check the quantity? I mean, after all, inside of our class, we do have, as a class attribute, the quantity. And so when I run this program, if we are adding this, I want to be able to say, well, no, this isn't correct. I don't want 3 of these. We want to actually track how many of each, but I want to do it all inside of one instance. I want to increment that quantity. And so what will we do? Well, what we have to do is, instead of adding this to the array list every single time just indiscriminately, whoops, what we want to do is we want to actually check to see if it exists already. And I think we can move on to, instead of hard coding this, we can say txt name.text and txt flavor.text. We had it hard coded before, but now we're going to actually accept it from the user input. So how do we do this? Well, what we have to do is, again, and this is really the core of working with data structures, is we have to loop through all the elements in that array to see if it already exists. Well, and what do we have is, we have the ability to track this name and match the name to see if it exists. And how do we check that? Well, through each one, what I'm going to want to do is say if my candy, this is a candy that we want to add, dot name equals our candy I dot name. And you're going to see that if it is a match, we want to add it to our array list. But we don't, do we? What we really want to do is we want to update the quantity. So that belongs in the else instead. If the name is found, then great. Otherwise, add it to the list. So here I'm going to say our candy I dot quantity. And we said, oh, that's not that. We don't want to do that. We want to do add one. But look at what's happening here. I know that my array list has instances of my candy class, but all I'm getting is equals, hash code, get type, toString. And what's going on with this? Well, with data structures like array lists, they don't keep track of, in this case, that they are candy objects. Array lists don't care what kind of objects you have. It treats everything as a generic data type of object. And what this does is it gives us the ability to reuse the array list for different types of values. So we can do strings or integers or doubles. It doesn't care, and this is nice. But the negative side of this is that when we want to get something back out, the array list, it acts like it doesn't know what it is that we want. And that's okay, because since we're the people that put it in there, we know how to get it back out. But it takes a little extra work. So what we're going to want to do is we're going to declare a temp variable and then set that to equal what is in the array list. And now since we have this in the temp variable, now we can work with it. And so yeah, we can see that there is a quantity, and we can say plus equals 1. But wait, quantity is read only. So what do we have to do? We said add 1. Let's try this out. Add candy. Oh, we need the debugger. Something's going wrong. And we can step through this and see what's going on. Keep using my F10 keys, and it's stopping my screen recording. So let's try this again. Alright, so it looks like we're losing that first if statement here. What's happening is after we do our add, our array count is 0. And so it's never checking this at all. So I think our logic is incorrect here. And so what we're saying is loop through everything in the array, check to see if it exists. And we're actually checking every element here every time. And what we're doing is we're only allowing it to add if it's in the array and the array is empty. And so we have to examine what we're really doing here. And what this is it's a very simple search algorithm. And so we want it to search through the entire array. If it hasn't been found in the entire array, then add it. And we're not giving ourselves the ability to do that. So what we have to do is we have to track this with a flag. And I'm using the wrong language here. There we go. Alright, so instead of adding here, which is fine, this is okay, but we have to have a way of breaking out. If that candy has been found, then yeah, this is great. So we're going to say add one to it and say is found equals true. We found it, we're good. Else, we would say is found equals false. But we don't have to do this, right? Because if it finds it, then we're going to say mark this as true and exit. But if it hasn't found it, well look, it's already false. So this is redundant. All we care about is if it is found, set this to true and break out of our for loop here. And then after our for loop is where we're going to test to say if it's found. And what we're interested in is if it is not found. If it's not found, then yeah, add that candy to our array list. So what we're doing is we're declaring the candy off of the user input. We're searching to see if it already exists inside of our array list. If it is, awesome. Add the quantity of 1, mark is found of true, and exit our for loop. Remember, we set the initial boolean to false here. If it's not found, then treat it as a new piece of candy and just add it right off the bat. And then when everything is said and done, make sure we update the list box. So let's add this. And it looks like it's only adding 1. And I had thought that we had updated this. Let's see what's going on with that. What we need to do here, again, create our temp variable equals our candy I. And then inside of that loop, temp candy dot name instead. I think I must have lost that edit somehow. Add, and we have that sucker going in, which is great. Let's try it with a different kind. And it's adding in a different kind for us. But during all of this, we're not having any way of actually seeing, okay, I'm adding 1, and we know that behind the scenes it's going through and it's incrementing our quantity for us. But we can't see that. We can't see what's going on. So really what we want to have a way of getting is some detail about that object that's in our array list. And so what we want to do is have that selected item maybe alter our form out so we can see what that quantity is all about. So on my form, I'm going to make some room and I'm going to add that label in. That's going to let us display what the quantity is. Remember that quantity is going to be read only. Instead of dragging that on there, I'm going to copy an existing label so we can keep the font size. Okay, I have my placeholder text here, which I'm going to clear out on my form load. Alright, so in order to be able to update that, what we have to do is tie into that selected index change. And we're going to use the same logic of being able to get that value back out. And so what we've done is we've taken the name of that candy and we've added it into our list box. So what we can do now is get that value back out. And so we have lst candy dot selected value. And let's do a debug on this to make sure that we are getting what we think we're getting. So I'm going to add that in there. I'm going to select it, and we got nothing on there. So instead of selected value, let's mouse over this and see what our options are. Selected value is nothing. Selected item shows up as string. So that's what we want in this case. Dot selected item. Okay, and that's something that we can use. And remember, just like we matched up to see if it existed already before we did the quantity, we can use this same for loop here to search for what we want. So I'm going to take that code here and paste it into this. And this is that concept of a search. And instead of looking for mycandy.name, I'm going to use the string that I pulled out from that list box and test each one. And now I'm not looking for is found. Instead, this is what I'm after. I'm saying look for the candy name to see if it matches that instance name inside of my array list. If it is, then temp candy is going to be what I'm working with. Now that we have the found object, I can update that label quantity. Label quantity text equals temp candy dot quantity, which is really what I'm after. And since I found it, I can do my exit for and skip out of that for loop early. So let's see what happens. Add candy, and I'm still on my breakpoint here. So cut loose, and quantity is 0. Okay, let's try again. Add, and now we can see that it's at 4. So something's not quite right here. Let's take a look. Add candy, and it does register, but it's showing up as 0. And why is that? Well, that's because what we're doing when we create a new instance of our class is we're not setting this initial quantity value in our class. What happens when you declare an integer without initializing it is you're going to get a value of 0. So one thing we forgot to do was to create a default constructor. And what that default constructor does is it gives us a way of controlling what these initial values are if we haven't set them to begin with. I'm going to do that right after here. A default constructor is defined by saying public sub new. And remember, we're setting these to be whatever the user wants to set through their properties, but we haven't given them a way to be able to set the initial value of a quantity. So that's something that we're going to have to do inside of our default constructor. And remember, this is what's called every time someone would say new candy. And let's see if this fixes our behavior. And yeah, we can see it starts at 1. and selects it in there again. What we should also do is, if I go through here, and let's say I was to add a red lollipop, you'll see that it's updating the quantity, but we have this name and the flavor in here as well. So I think what we want to do is we want to update these values as well as the quantity values to display properly depending on what is selected. So in here, what we should also do is not only update the quantity, but say txt name.text equals tempcandy.name, and txt flavor.text equals tempcandy.flavor. So now add one for my sucker, add one for lollipop. Let's make this a little more interesting. Lemon. And now let's say one more. Jolly Rancher. Watermelon. And now we can see it's updating depending on the candy that we have. So we just have one more piece missing now. And we want to be able to say, I want to eat one of these. And tie that functionality in as well. So now, double click on the Eat button, and what I can do now is the same thing that we did for our add. And in fact, I'm going to copy all this code out. Everything inside of my button add, I'm going to copy into my button Eat code. Because we still want to be able to search, we still want to add, but instead of add one, remember we've defined some code for eat one. And the behavior is going to be different now. So if we eat one, we're going to decrement that value by 1. And if it's not found, we're not as concerned about that. Mainly because if something was selected or if it's not found, then we don't have to worry about decrementing that value. So we can delete this line. But instead, really what we want is, if there is 0 left of quantity, then what we're going to want to do is we actually want to remove that instance of the candy from our array list. We're not going to list it as being part of our bag anymore because all of them have been eaten. So we need to test to say, in this case, and this is going to be if it is found, we're going to say if temp candy dot quantity equals 0, then what? Well, we have to have a way of removing it from our array. And what the array list gives us, very convenient, is rcandy.remove. Now there's two different ways you can do this. One is you can remove it by index, and the other is you can actually pass the object in, the actual instance of the object in that you want to remove. And in this case, we do have the instance. That's temp candy. So we can just pass in temp candy, and it will take care of the rest for us. Now, one thing to keep in mind is you can get sort of unexpected behavior if you remove something from a list, a data structure, and then continue to loop through the rest. Because kind of what you're doing is you're pulling something out, and by pulling an item out, you're also affecting the count. So the original count might be less than what you thought it was. So in this case, we're taking care of it by actually jumping out of the for loop before anything gets weird. But it is something to take into consideration. So let's see what happens now. Add this one in, and we can say we have 3, and I eat 1, update it to 2, to 1, and then on that last one, we get rid of it. So now eat 1 and eat 1. And so what we have here is really a nice way of being able to manage these objects that are inside of our array list. Not only are we able to access them, but as we select them, we're also able to pull out the attributes on each instance. Depending on the quantity that we have set, we're even going so far as to removing them from our list altogether. But if there's one piece in this code that seems a little tedious, it's this whole search thing. You know, what we've been stressing pretty much since you probably started coding is if you find yourself copying and pasting lots of code, you're kind of setting yourself up for trouble, because if you go through and you have to update the logic, you have to update the logic in several places. So if there's anything that should be raising some warning flags, it should be this block of code right here. And there's really no way around this when you're using ArrayList, but there is a different data structure that makes this a lot easier for us. And what that is something called a collection. Now, we've been using the array list, but if we go in and change this to collection instead, you'll see that we really don't get that many errors of going through here. And we do get some, so let's see what we have to do. This one's easy. That one's just because we're using the wrong data type. And then we get this one here though, which is remove. So let's see what we can use instead. And we have remove, but it goes for something called a key as string. So let's fix this and just comment this out for now, because we need to revisit this. But a big difference between an array and a collection right off the bat is that a collection is actually going to start at 1 instead of 0. So we have to fix that in our for loops. Because it starts at 1 instead of 0, we go to count instead of count minus 1. So I have to go through wherever I'm looping through my array and start at 1 and 1 to count. And there, that's cleaned up. But the other thing is let's take a look here and let's look where we're adding this to the array. You'll see that the syntax is really the same of adding to a collection as it is for adding to an array list. But now we see it's not just add as you do the mouse over and IntelliSense pops up. Instead, when we do .add, we can do that, but it's overloaded as well. And what we can do is we can add the instance of our object here, but also it gives us this ability to pass in something called a key. And this is the concept of what we would call a key value pair. And what a key value pair is all about is that the value is going to be your data, but the key is going to be something that's unique that lets you look up that object very quickly. So when we're talking about something as, for example, a student in PeopleSoft in myfvtc.edu, for example, you have a student ID that makes you unique. Alright, I keep getting booted out of my screen share, so hopefully this makes sense compared to where we left off. But in PeopleSoft, you have a student ID that makes you unique. And it's not just for the fact of keeping you unique so that your records don't overlap into someone else's. I mean, that's a big part of it, but really the reason behind it is that it is also a very fast way of getting all your data. It's fast because of the fact that it's unique across the board, so that it can be retrieved with that value and then you and your data itself are the value. In this case, an instance of our candy class is the value, and the key is going to be whatever we tell it to be. And in this case, what makes the most sense is for us to say myCandy.name. And the key is going to be a string, and that string then is going to be used to retrieve the instance of the class after that. So what does this really do for us? Well, here now, inside of our for loop, when we're doing a search, instead of looping through every single element and having this Boolean flag, instead what we do is we say if our candy dot contains, and this works just like the string contain did, true if it contains it, false if it doesn't. And what we're interested in is if it contains myCandy.name, then that means it is found. So now we go back to our approach of temp candy is candy equals our candy. And now, whereas we used to do I for an index, 0, 1, 2, 3 to whatever the length would be, now we can use that key instead. And we say myCandy.name, and that will return it. We don't have to loop through it anymore. What this will do is, instead of going index, it lets us use the key as the index, and that pulls that back out. So if it contains it, grab that, and we say temp candy.add1. If it doesn't contain it, we say our candy, dot add myCandy, which is the value, and then myCandy.name, which is the key. And so that dramatically simplifies what we were looking at. Let's take a look at, see what it does for removing. Oh, that was removing. Whoops. Let's take this code and move this into our button add. There we go. Now let's do the removing of one, or reducing it. And we can actually use a lot of the same code. So what we're going to do is we're going to see if it contains it. If it does, we remove one, or eat one, which would reduce the quantity by 1. Then, just as we did before, temp candy.quantity equals 0, and we would say our candy.remove, and in this case we can remove it by index, or we can also remove it by the key, which is what we're going to do. myCandy.name. In this case, if you recall, we didn't do myCandy, we did lstcandy.selected item, and that was the key string for it. And we don't want to add here, so that's also something that we're going to get rid of. Okay, run this again, add one, remove one, add one, uh-oh, argument key, not a valid value. Selected item. Okay, so what we did is we weren't checking for null there, which is okay and which is expected. You can't do a search on a null item inside of your array list because it's not gonna work. It's not gonna find it. So what we have here is sort of a hybrid array list, and what it does is it gives us the ability to add a bunch of items into a data structure, but then set it as a key later, so that we don't have to do that whole for loop search. And the reason that's more efficient is that Imagine you're doing a for loop search and you're checking each name to see if it equals whatever you're looking for. And best case scenario, it's going to be at the first spot. But worst case scenario, it's going to be at the very end. So you have the potential for your search to be very inefficient. But when you go through and you add a key, your collection will actually sort the data for you using some algorithm. And it's going to be much more efficient in terms of how it's going to go out and find it. And you know, it's one of those cases where, sure, a list of 3 or 4 items, you're not going to get much of a performance gain. But if you start talking about collections of hundreds of items, you can see where that starts getting more of a payoff in terms of a performance increase on top of that. So this is going to be something that we're going to be using in an assignment. We're going to actually be tracking vehicle VIN numbers, and you're going to be searching on those VIN numbers and working with the contents of those collections as well. This finished code will also be in GitHub, marked in a folder just called Candy Project. Again, Candy Project _ no code is going to be the starting point, and this code would be the end point as well.